Hi everyone, welcome to my stream. Today's topic is to implement infinite terrain chunk loading. So currently we have a fixed for loop on loading terrain. I think it's here. When we generate like 10 by 10 by 7, so 700 chunks every time when the program start, which already get a little bit slow, and also the map does not feel big enough. It's like we can easily go into the boundary and just go into the darkness. So the topic today is to generate terrain on the fly instead of have generate all of them at the program start. I have some idea on how to implement that, but I have to say my idea is not really solid. So let's see how it will goes. Hi, welcome to my stream. Uh, so let's see how it goes. So first thing first, in the chunk manager, I want to have an update function, and I will expose that function instead of the load chunk function. So update will handle everything basically, and it should be called just per frame per update. And this parameter is also called position, but it's different from this position because this position is this position is an integer position of the trunk, but this one is this position is the position of the camera. So I have a point class. I can even use this point class. It should be the same. So if we put this code at here, let's just ignore the position for now. Our camera does not expose the position. Also, this class from learnopengl.com is quite bad, I should say. It has all kind of problems, these cameras, and I need to refactor, just rewrite the whole thing soon for my own sanity's sake. Let's quickly add a getter for the position. And now we don't need to expose load chunk anymore. The program is still the same. So the idea then is to call this update per frame instead of the program at the program starter time, but that needs a further refactoring because currently we just load chunk. We just load chunk every time when we just load chunk every time, whether we need them or not. So if we call update twice, we will just do the same work twice, which is not really helpful. So let's already include our order set. That can be useful. Later, I may need to change this to unordered map. But for now, the idea is we have a hash set for already loaded chunks, so we know with chunks we don't need to load them again. And in here, I can say this. If loaded chunk does not contain chunks coordinate, then we load the chunk. And that can work. Not very efficient, but that should work. And then I think we can get rid of this generate mesh. Let's see whether this not very efficient code is at least efficient enough that we can run it per frame. Also, we currently don't have like fixed timestamp update instead of variable timestamp rendering, like just normal game loop. That's kind of thing I need to do later. It looks good enough. You can notice currently I'm using 3D poly noise to generate the terrain, which I like. 3D poly noise, it can generate some interesting features of the terrain, but on the other hand, it generates something like this, which is certainly not acceptable in the long run. So we need to use a 2D poly noise to generate a height map and then have a 3D overlay. instead of just 3D all the ways. Okay, so now we have update function per frame. Let's change update. Let's change this a little bit. Shouldn't really change anything. Let's now consider the position. I don't think I have a position to. Yeah, I have an opposite calculate trunk transform function, but I don't have a position to the chunks. So yeah, how to get from position to the trunk coordinates? If we cast asks into an int, then we can divide by chunk dimension. What is? I think that's it. Let me think. We need to plus half the chunk dimension. Like that. 6. Yeah, I think we need that. So I think we can even just do that. I don't know. It's not considered that yet. Something like that or something like that? No. Because it's int and float. Maybe I should make my math library more flexible to handle this kind of stuff, but currently I can't. And then we have a xy, the offset of the point, but our for loop still doesn't consider it yet. Also, currently we are using y-up, but I want to use the up later. That's why I use this horrible trick to mimic the up. Now we should have infinite frame loading. That's quick. Of course, we will have a huge lag when we kind of move our camera. No, we don't have. We don't load any new stuff. Why is that? Okay. It is loading. But I think some of the calculation is wrong, which caused. Some calculation is definitely wrong. And the lag is not as big as I think, which is good. So I thought this would be a really hard thing. If this will work, then that will be great. Of course, this is certainly not efficient, but there's something wrong with this calculation. Also probably a good idea to have a 3D bounding box or something, and then we can iterate through that. It provides a proxy iterator which will just collapse this whole for loop business. So I don't need to do that, but I don't have that implement. Or we can just use this. The initial position looks right. Sorry about my point being that debug hostile. That is also something I plan to fix in the future, which is use less this kind of CRTP technique to flatten this inheritance, so it will be more debugging friendly. Continue this. Yeah, now we have some serious problem at here. So let's say y h should be 0, negative 38 should be negative 1. This should be negative 5 or something. But that is not what I get. Well, this is negative 5. But if this is negative 5, become negative 10, Or maybe it's because I use this horrible hack to mimic the app and that caused a problem. Yeah, let's don't do this hack at least for now. Yeah, that is better. Also, it's really fast. It's faster than I imagined. So we just implemented infinite terrain loading. Even though you can still see a lag when we actually load the terrain, but it is infinite. We don't release any memory though, so we just use more and more video memory. But it already looks pretty good, so let's commit that. Oops. That's why we say we never know how much time we will spend on this kind of stuff until we actually start to implement them. Because I thought this will take hours and it just take 20 minutes. That's really nice. And but the next step is I want some way to unload the chunks. If it is out of the range. How to do that? We can't have another set. Oh, not even a set. Like, yeah, maybe a set will be. This will be tricky since our chunk vertex cache do not know anything about it. It has this transform which don't contain the original chunk information anymore. You can certainly add like original trunk coordinates here, but then this structure is kind of bloated, and this information is not used for purpose other than deletion. We can also make this unordered set become unordered map, and it map to the indices into this vector, but then the problem is what we change something in the vector. Thank you. Thank you, Robin. I don't know why you are thanking me, but yeah, thank you, Robin. I hope you enjoy this. Because currently I'm just thinking about how to implement that. We can change this whole thing into an ordered map. That doesn't sound very efficient when we need to iterate them, but whatever. We can always optimize them later. Now this breaks this API of Vertex Cache getter here, where I use Vertex Cache. When we do push constant, we need the pipeline layout, so is pipeline layout the only thing we need? So we can totally put this into our... So instead of exposing Vertex Cache directly, we have build command function that will just loop through the pipeline layout and the command buffer. What is offset? Do I really want to do this? Maybe not. I need to pass too much into this build command functions to make it work. But I also don't want to expose this. Yes, I don't have much choices. output. How to use this thing? No. Insert. In place is probably better. And then in here, no. Same kind of deal. But it becomes super slow. Seriously, what I've done, is iterating ordered map is that slow? Yeah, this is the only thing I changed. Oh, it's because of this. Shouldn't matter because should always be reference for the structured binding. Now that doesn't work. At least we already implemented our initial goal in like 20 minutes. Yeah. So how to do this? Apparently, iterating through an ordered map is so slow that it's not useful per frame. I still don't understand why it's that slow though. How much elements we have? Like 1,000, and it's less than 1,000 because oh, let's see what is going on here. With that map approach, we don't handle empty chunks, so every time empty chunks just get reloaded and then discarded. That's why it's that slow. Because here I said if it's empty chunk, we just returns. We don't put anything into the vertex cache. I guess I don't like this approach. Let's stash it. Even if I can use an optional in the map to make it work, I still don't like this approach. So instead, I have a vector of caches. I think maybe it's a good idea to use an ECS like ECS style kind of sparse set approach where we have a back indices or something. How does that works? Um, we have this vertex cache. We want it to be continuous. That means we will move items around in it. Oh, maybe we can get away with having some hosts in it, but then allocate stuff to it afterward. Um, that sounds pretty complicated, but where's my... But I guess this way we can have stable addresses. So that is good. So we can have something like this. Let's say this is our first block, second block, third block, fourth block, but then we delete the third block. We definitely need another array to keep track of that. So another array. Oh, we can. Guess we can just use our hash map. Well, no. Another array will implicit linked list, like every empty block linked to the next. That can work. That sounds a little bit weird, but that can work. Yeah. That is definitely something I will abstract, but also let me implement this first and then see how to abstract. Also, this will probably take a long time, so it's not like quick 20 minutes hack anymore. If we want to have an implicit list, it's like something like that. And how's that for Vertex Cache pool size? Let's say 1000 for now. So we can have 1000 pull on the fly in the total instead of a state vector approach where it can grow. The reason I will not use state vector anymore is because we need to initialize this, which becomes a little bit tricky with the vector because we need to do extra work. Wait, with this okay, I see. How delete stuff though? When we delete stuff, then we just add it back into the. Okay, I see. I think this is called object pool. Let me just check. because I think this book has an implementation, so better to see what people does. Use a bool to keep track of stuff. Yeah, that sounds a lot easier than the implicit list. And yeah, I'm overthinking because implicit list is an optimization, and all the optimization can be done later. So yeah, goodbye union. This way we can even just have a bool. I guess I will implement it in here for now, and then later. But then also in here we don't want to give the give back uninitialized. Whatever. If it's uninitialized buffer, we just ignore it. We can, and we don't even need a bool. We can, let's say, we can just use this buffer status to check whether it's initialized or not. Okay, that works. That's dirty, but it works. How to push stuff into the pool though? Okay, first available, yeah. Now we have everything we need to implement this. In here. Why? Okay. Let's just quickly make, well, I guess just make a struct for this. it will be a class with private. Those two are private members later because they have invariant, but for now that's easier. Yeah, but still without the implicit list, how to get the next one is union. Okay, I see what is going on here. We still need the union. Oh, why I cannot initialize that? This chain shouldn't have a non-default constructor. Why it has a non-default constructor? That should work, but that is not what I want. So for this, or I need to do a third field. Third field don't know the next position though. Yeah, that's about right. Then it's first available. Did I use a pointer? For the push, maybe push is a bad name for this. Let's call it add. For the add, what we will. Why does it member initialize is redundant? For the add, I don't care. Auto add this. Also, this is -1. Okay, the last one is no pointer. That is right. Vertex Cache. What size? The first. Oh, it's just this. This will happen if we exhaust the pool. Which shouldn't happen if we use them correctly. Yes, first available becomes item pointer dot next. And we really don't need pointers for this anymore. You can totally use the reference. well, we can't do that. Maybe we need that. Yeah, we have add. Hopefully that is correct. I think it is. No. Now, Vertex Cache 4 will have stable address, and that can be easily, we can just easily remove stuff from it. And easily index into it, as long as our index into our map get destroyed at the same time. So that's good enough for me. Now the problem is how to implement this. We can't really expose the span. Since internally we use these items, I guess we can use the pool. Let's add the pullback instead of using undefined behavior because it's not really that much, and undefined behavior is not cool. What do they call it? I just want to look up what's the name they use. The particle is linked list itself. I feel like I still don't totally understand what is going on. Uh, I'm not sure if I. Yeah, they don't use union, which makes things just needlessly complicated. But using union can save some space because it really doesn't matter. I just make like my life needlessly complicated. So uh, this what is it? Premature optimization. Blah blah blah. That makes my job much easier. I don't even need to change this interface. Let's make sure this thing. Yeah, I think this will work, but let's make it a little bit more explicit to say it will be not handled if does VMA has a null handle? I think wiki null handle works though, so and we can implement iterator for this. for this cache pool, but let's make it work first. No, not 0. What am I doing? Yeah, I guess we can check vertex count. Yeah, we can check vertex count. Since we initialize it to 0, right? Yeah, the same as here. Wow. We explode in the ad. Okay, let's do this. Didn't work. Why? It's wrong. It's the same kind of stuff we exploded here. That's not really helpful. Two. Ah. Yeah, I just think the union approach is better, because this thing doesn't exist in normal circumstances. But that's optimization for later. That works. It works. We should explode at some point because we haven't released anything from the pool. Oh, we're still running. We are still running. What is going on here? Oh, okay. That makes sense. Because our process is pretty large, even for 1000. So next thing we can do is actually implement unload. Let's first we have enough stuff to implement unload. And let's return the address. And our order set become ordered map. I have X3 and and a pointer to this. We don't even need to modify them, so well, I guess we do. Maybe unload stuff. Hello, thank you for your video, Diego. Yeah, thank you for watching. It's fun to code this kind of stuff. What ID are you using? I'm using C Lion. It is most feature complete ID in the C++ land currently, I think. The downside is it's not really performant. Sometimes it will stuck because it's yeah, I don't know. It's reached. I want to say it's reaching in GC languages. The reason is so slow, but to be honest, I am not sure. It gets better though. C-line used to be unusable with anything template related, and now it's much better. And in here, in the load chunk, we can also return the pointer. If it's empty chunk, we return null pointer. Otherwise, we return the place we just added. And then in here, we first load chunk. That should be the same. Now let's say this. If anything in the loaded chunk is outside of this range, we just unload them. So we can have another loop. We can have another loop, and then we can say I guess this is the coordinate. I really need to implement some bounding box class, so I don't need to write this kind of code again. I do have an implementation of bounding box, just probably not ready for production use. It's only for floating point bounding box, not for integers. This sounds really wasteful though. Let's see. If it is outside of this range, then we can safely say that we don't want this chunk anymore. If it is null pointer, we ignore that, because null pointer means that our chunk is our trunk is totally empty, and then we want to keep it in the loaded trunk. So this way we can just reuse them later. But yeah, how to remove? How to remove stuff? So maybe I should use an index instead of this, but let's say if I want to remove this, then the first available can point to this. I guess I need to say this. Vertex count equal to 0. Buffer, we need to release that. I don't have VMA allocator here though. We should implement REI for this. It's also something later. If we have REI for the buffer, it means we pay some extra cost to always have an allocator here, but then we don't need to deal with this kind of memory management anymore. Yeah, we can just do that. Even remove that. I guess we can't because we use this pointer here that we still need. I guess we don't need this pointer, so yeah, we can do that. Something like this. Hopefully it can work. Yeah. Where is our thing again? Now we want to remove stuff. So I'm just trying to find the code. No, not here. Oh yeah, it's here where we see if vertex cache pointer is not null. We that hopefully will work, so we can just load terrain infinitely without exploding. Let's go, let's go. Go, 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 go. This seems already have passed the limit. Oh, I said it too early. Is our pool not large enough or something? What if we do this? Does it still explode at some point? Ah. We're not really deleting anything, are we? Should be like this. Yeah, another reason to have a bounding box, because this kind of code is really error prone. Oh, it's just all. It should be just all the way. We don't even need a single end at here. My fault. And now, I see what is going on here. It's because when we trying to free that buffer, it is still used in the what should I call it, in the frame. So we cannot just free it. Instead we need some kind of, we need to use our deletion queue. We don't have a like frame-based deletion queue yet, but we need a deletion queue that will delete our buffer when none of our frame use them anymore. That will be a kind of a tricky thing. So I think I will end the string here. We achieved quite a lot. Let's just remove this code for now. I have tons of refactoring to do already, and after doing refactoring, I will consider to implement that and implement how to gracefully delete the virtual memory without when they can still be on in the fly rendering. So that will be the topic of next stream. I still have tons of refactoring to do with currently this structure is totally a mess. So I will end it here. I guess I can do the commit stuff later. And thank you folks for watching, and